Hi everyone, so we will continue on our decision tree, but this time we will take the classification tree. So please don't come to this lecture until you to back to the previous lectures because both of them are connected to each other. So we talk about regression tree and we said at the terminal node the leaf, the prediction is the mean of the response variables. So at the terminal node the predicted he will calculate the mean of the variables. For example, if we need to predict this is make out of 10. So in the leaf we have values 6, 7, 8. So he will take 6 plus 7 plus 8 and dividing by the 3, and the predicted is called the average equal to 7. This is in the regression tree. The regression tree will calculate the mean is equal to the average of the variables because we predict numbers. So he will take whatever the summation they have in the terminal node and the child node divided by number of node, and then he'll give you the average. But in the classification tree, the one that we will cover today, at the terminal node the prediction is the mode, and mode is the most frequent category. So if we have at the terminal node we have pass, field, pass. So he will predict pass because the majority in here at the terminal node we have pass. So he will predict pass. So how is work? We said that both of them, classification and regression, they use recursive binary splitting, and this one is dividing the dataset into two groups based on conditions. So in the regression tree, the condition is use the RSS, residual sum of squares, to decide the split. So the split in the regression tree is based on residual sum of squares, and the RSS is the difference between actual values and the predicted mean in each region. And then the split choose is the one that minimize the RSS, and then the split will give you, he will predict the one that have the minimum RSS, reduce error the most. But in the classification we don't use the RSS, there's a three method to split our data, and one is called classification error rate, the second is called Gini Index, and cross entropy. So the idea, for example, in the regression tree, he will calculate the mean and he will decide the prediction. For example, we have here 4 students, we have 5 students here, we have 5 students, this is 4 of them are pass, so 4 divided by 5, this is 0.8, so he will predict this one as pass. And here we have 2 out of 5, so he give us 0.4, and this is only 0.4 pass. But in the classification, he will take the majority, since the majority in here are 4 out of 5, so he will predict this one as pass, and this one 2 out of 5, so that means we have a 3 field, so he will predict this one as filled. And this is a G for a purer, this is D for a purer, so this is the Gini index and cross entropy that will help to predict in the classification tree. So it will help the classification tree to split the data based on the impurity. So how these classes are mixed in the node. So let's gonna open our RStudio and check our data. So I have my movie data. I just imported by use the CSV read.csv function, and I use my I just name it as a df. I'm gonna run that, and then it's gonna give you the summary. To check our summary of my df data, So in the summary, same. I found in here in the summary, I have in one of my data. First thing, as we said before, you have to check if you have any missing data variables. So if you have any missing variables, you will see you have NA in here. So this one there is not NA, there is one NA. I have only in time taken NA. So that means this one I have missing variable in here. So we talked about that in the previous many times, but just it's good to repeat again. And then we need to remove the missing value. So we use two functions. One is s.na to detect all the missing value in the time taken, and then we replace all the NA. We remove them and replace them with the mean, so we don't have any missing value. And this is the function how to remove all the missing value and replace them with the mean. And then we have to split our data. To split, you should check your packages. You should use the CA tools. So use CA tools to split your packages. So we use you have to set your seed when we talk about that why. So you will have fixed value every time you run your code. Okay, and now here we go. It's gonna do our classification tree. First, it's gonna fit. We need to. I'm gonna name it class tree equal to. I should use rpart function formula. So formula equal to. So in here I have my DF files, the CSV file. I have my start tech Oscar. I need to check if the movie have won an Oscar. So predict 1. If the movie is not win Oscar, so predict 0. So start tech Oscar, it's gonna be my independent variables. Start tech, okay, Oscar, and tilde dot, this is for all my independent variables, data equal to train, and I have this train data, where is equal to 0.80% from my data, and I should use the method, and method equal to class, and use the control equal to rpart dot control, and I'm gonna use the maximum depth to limit my tree to only 3 layers, and click on that. Okay, there we go. So this is my class tree. This is rpart, the function that we use and to calculate our tree, to build our tree. Formula start tech, this is my independent variables. So I'm trying to calculate if this one is win Oscar or not. And my data equal to train. We use the difference between this method and the last method. We use the method equal to class to differentiate between regression and classification, and this is control equal to rpart control maximum 3 to just set our. So let's gonna now plot our tree, and we see. So rpart dot plot. So my class tree, my model, and need the box. So the box dot plotty, I need to, this is ROPU, this is to give me color, and then I have my digits, yeah, -3. I'm gonna check that. Okay, I'm gonna name it gray, for example, because this color is not working. There we go. So now we can check if so my 100 population, I have only 54 is the average. I have the 54 average from my 54 average. This is nominated to take an Oscar. And so the model start with the collections is less than if the collections start with the if the collection is less than says 78,000. So if yes, we have 99, this is 92% is only 51. So 51 chance this one's gonna win the Oscar. And if it's not, if it's bigger than 50, the collection is more than 78,000. So there is a 99, there is 96 chance this is the movie gonna win the Oscar. And if the budget is bigger than 3,000, and this one this is their 50, there is a 48 chance this is not gonna win the Oscar. And we have 92% chance this is the movie if the budget is more than 3,000, this is gonna win the Oscar. So this is how the classification work. Now let's gonna check our predict our data on the test. So test $sign predict. I'm gonna predict and to check our data on unseen data. So predict our model is called class tree, and the data equal to test. We check on the test data that we already separated on the 20%, and we have to set the type here equal to class, and we run that. So if we go to the test now, we'll see we have a predicted value. So we have this is start take Oscar, and we predicted value. You can check we have 1 1 1 0 1 1 0 0 0. So you can check your model, the predicted model, with your actual data if it's fit. It's impossible to get 100% fit, but at least you have the less minimum error. And if we need to check, like build a table between them, so we can easy to check table. I'm gonna build my test $sign start take Oscar with test $sign predict. So if I can check now from like I have 64, so I have this is 45 plus 19, I have 64 as 64, this is the accuracy from this model, and I have 43, this is wrongly classified. So the accuracy is given me from this one classification is only 64, so you can compare it with the other prediction model that you build and choose your model. So this is in the next video we'll use the advanced tool to enhance our accuracy for decision tree. So thank you for your watching. Please subscribe and leave me a comment if you have any questions, and see you in the next videos. Thank you for your watching.